you're not going to just be able to go any place and drill a well and start injecting carbon dioxide. If you do that, it'll just come back up. So we developed this idea of sort of a geological storage safety and security strategy that involves a number of different elements, starting with making sure we really understand the science correctly, developing techniques for characterizing sites and selecting sites, to develop a whole field of storage engineering. We have monitoring programs to make sure that our predictions are reliable with regard to where the carbon dioxide is going and that it's not leaking out of the storage reservoir. We need to have regulations for this. This will not be an unregulated activity. And finally, we need to develop approaches for long-term stewardship. And one of the important ideas is that in addition to having a seal for the storage reservoir, there are other ways that you can contain the CO2 underground. And one of them is it dissolves in the aquifer water, and anywhere from say 2 to 5% by mass can dissolve in the water. And once it dissolves, it's not going to be buoyant anymore. As a matter of fact, it's denser and it wants to sink. The second thing is that CO2 can also be trapped by capillary forces. And this happens after you stop injecting. As the CO2 sort of arranges itself underground in response to buoyancy forces, some of the water wants to come back in where the CO2 is. And when that occurs, that it makes, that it disconnects the CO2. So you have these sort of ganglia disconnected CO2, and those are immobile. So that's important. CO2 can also be converted to carbonates, magnesium carbonates, calcium carbonates in situ. And obviously once that happens, it's essentially permanent. And similarly, adsorption to coal or other kinds of organic matter in the subsurface can permanently chemically trap CO2 underground. The density of natural gas is about half of the density of carbon dioxide. And we know that there are many trapped natural gas formations that lasted millions, tens of millions of years around the world. So a fluid which is conceivably even harder to store natural gas than CO2 has remained underground for millions of years. If we're going to meet very deep emissions reduction targets, we're going to need to think about capturing and storing CO2 from natural gas-fired power plants as well. So I just want to stay out of the box that says carbon dioxide capture and sequestration is really a clean coal technology. It's much broader than that. So we think that we know how to drill wells, we know how to inject fluids, we know how to monitor them and so forth. So we think that not only nature can do this, but that humans can take advantage of these structures. That there's lots of evidence to suggest that CO2 in a natural system can be trapped underground for the time, much longer even than we're talking about.
Energy from coal does that for me.